Hello and welcome. This video is a re-upload of a previous video I recorded in August of 2018 in two parts. So I combined the two videos into one for your viewing pleasure. Enjoy. Here I have some samples of monazite. This is monazite as it comes out of the ground. This is a mineral source of rare earth. And here there's the same thing grounded, finely grounded. We're going to try to extract thorium out of it. This can be found everywhere on Earth. Thorium has been considered as a new source of energy. It's not fissile, but it's fertile. It can generate uranium-233 and be used in a reactor. This seems fairly straightforward. So we're going to try. Maybe we'll fail again, but try to get some thorium out of this. Usually contain about 10% at the very most, but usually less than 10%. Just going to do a quick gamma spectroscopy and see what's in this. Let's get started. Let's put the monazite in there. So right away we have this large peak right here, centered around 250 a keV. This is probably lead-212. Which is a daughter of thorium. We have a few here. In particular, we have this one. Let's see, we have some actinium-228. As far as uranium and radium, we don't have too much. You usually hang out in this area, 180, 140. We don't have too much in here. There's no gamma ray, or very little, coming out of thorium. Only alpha particles, and until I get my alpha spectroscopy fixed, I can't detect it directly. But what I can do is use my XRF setup and see if thorium is even visible in this monazite. So we have a couple of peaks that show up. We have more than two. We have there you go. So we can stop it. So we have these two main peaks right here. So we have this one at what we at 1294, so that looks promising. And this is the second peak at 1620. We're at 1611, so that's pretty close. There's another peak right here. I'm not sure what this is, and these other two there. But with X-ray fluorescence, we can see that there's indeed thorium in there. Let's see how much monazite is in this sample. 138 grams. So write this down. We're just going to add sulfuric acid. So this is concentrated sulfuric acid. It's going to have to cook for 2 to 3 hours at 200 degrees C. Unlike uranium, thorium only has one oxidation state, and it's plus 4. So it also is not very soluble in a lot of different salts. Let's say 220 in case 428 Fahrenheit. Okay. All right, down to the. Nah, you didn't think I was gonna cook radioactive material in concentrated sulfuric acid in my own stove in a garage. There you go.
3 hours later.
After some time to cool, this is what we got. This is mostly solid. You know, we get this sludge. I should wear some gloves. I'm gonna put it into this bigger beaker. I'm gonna add the water. Add some water carefully because it's still very acid, so just a little bit. It's gonna heat up a lot. Just take it slowly. The cake at the bottom, it's gonna be a pain to remove it. I hope all of it reacted. With 238 grams to start with, I don't expect to recover much more than 20 grams of thorium salt, if that. You know, in the best case scenario. Ah, crap. So this is a first filtration. See what we got. Once it's settled down, we have this the filter. I put whatever precipitate is here. That's what we're looking at right now. It looks like we have the lead's right here, and the thallium, you know, the thallium as well. But it looks like the actinium is still in solution. It doesn't show up here. So interesting. Let's see what's in the solution. Here's where the actinium went. It's here. What else we got in there? We might have some uranium, trace amount of uranium. It's showing up on the, so there it is. Yeah, thorium is in solution. Yay. Okay, I don't have a centrifuge, so I guess I'll have to let this sit and for a few days and see how much it clears up. So after many filtration, we have this beautiful bluish green color of a solution. It contains a lot of rare earth like cerium and lanthanum and a bunch of other lanthanide. The one we're interested in is a thorium. So they might be in phosphate and sulfate salt. Yeah, so I made a solution of sodium hydroxide off camera here, and I'm dripping dropwise a few drops of it into this thorium solution here, and it started immediately to get cloudy. The higher the pH gets, and more metal will precipitate. I think the key is to keep the pH at about 1 to get only the thorium. So I don't need all this. Oh yeah, we're still plenty acid. So from blue it turns into this milky white over time. The pH is still kind of low. It's still around 1, or maybe even lower than 1. Turn that off now. So here's the filtrate. I put it in this bag here. This is mostly the phosphate of thorium and different other elements. On the gamma spectroscopy, it has something interesting. So we can see it has thallium-208 in it. Thallium-208 only has like a 3-minute half-life, but it has this very energetic peak at 2.6 MeV. I'd like to point out that the US NRC has a limit for the radiation dose for the general public. And according to their section 20.1301, they have a limit of 0.1 rem or 1 millisievert per year, not to exceed. And not to exceed 0.02 millisieverts or 0.002 rem per hour. So 0.02 millisievert is 20 microsievert per hour. And not including the background that the general public, including myself, cannot be exposed to. Here where I live is between 0.12 and 0.15 microsievert per hour. So I've been keeping track of my exposure in these last few days, and the total, including the background radiation, is somewhere around 1.06 microsieverts. So basically I would have to do this for 1,000 hours every year to exceed the recommended limit, or about 20 hours a day, and trust me, it's not gonna happen. So we're safe here. We're good. So here is the oxide left. The XRF is giving me a big hit for thorium, and here's the sulfuric acidic liquor we were left with. Maybe concentrated this down a little bit. All I had to do was simply add cold water. It will have two effects. It will increase the pH, and it forces the thorium out of solutions. Since it's the least soluble metal in all of these rare earth and iron, and simply added cold water. So that's what I did. So here it is. It's right there at the bottom. So I'm going to filter this and dry it up. And this is, I don't know, the literature is a little confusing on it. It might be thorium phosphate with some sulfate, some oxide. And that's really that simple. Here's a thorium salt right there. It's probably not nuclear grade, but this is what you're looking for. Wash it several times. So first a quick and dirty filtration with a coffee filter, just to try to get rid of most of the water, and then followed by a bunch of rinse. Okay, it looks like we have a good rinse here. Nothing else is going on. There's nothing going into the precipitate. Okay, just for kicks, I'm gonna show you I'm not out of my butt. We're still very acid. Now I'm gonna add some concentrated ammonia, and if there's still any thorium, it should precipitate. If not, then nothing happened. And nothing happened. Now if we add more, we're gonna start getting the rare earth out of it. But we're good. I think we got it here, most of it. After further investigation, I discovered that this was thorium sulfate. I'm gonna put it in the XRF. Okay, so now remember, with the XRF I can't see at least with my setup, I can't see phosphorus, oxygen, sulfur, any of this. All right, so we're expecting two peaks at one at 1297 and one at 1620. So we have one here that is at what 13. Yeah, it's good. And this one right here at 1622. Oh, and there's also this tiny peak down here by 19 keV. It does show as L beta at 1898 on the library of XRF spectrum for pure 99.99% thoriums. Good news right here. And apparently there is no other metal, heavy metals, than thorium in this mix. And that peak that was showing up earlier on the other video here is gone. So we successfully removed what I believe was iron. And here we are, all dried up. This powder is mostly thorium salt. I kind of want to get the metal out of this, but I don't have a furnace and chlorine gas to pass through it under pressure, high temperature, all that fancy shit. I have an idea though. If you ever watch the YouTube channel Nerd Rage, he has tons of fantastic experiment, very professional, some more complicated than others. Very good channel, highly recommended. He does this thing with sodium. I had the idea maybe I can try with see if it works with thorium. Let's first cut a very small amount of sodium, maybe even half that to begin with, like this. I'm a little nervous about this. Let's try in really small quantity first. Sodium is just about to get liquid here. I'll catch a chunk. There you go, see? That right there is liquid sodium. Now this has gone on for a few minutes, and I'm let it keep going a little bit, maybe add another small chunk of sodium. Well, unfortunately it doesn't look like it's working. I can still see beads of sodium floating around. I might just cut my losses and I know I can just add water, right? Because metal oil is not going to mix with it. Sodium is going to react with it and dissolve in it. If there's any sodium salt, it will dissolve in the water, and we'll be left with what we started with, the thorium salt. And if there's any thorium metal, we should see it, right? Yeah, that didn't work out too well. Not a good idea, but it was one idea. Still somewhat of a decent success. I mean, we did get the thorium out of the monazite, so it's not all bad, right? So yes, I did get thorium sulfate in a fairly pure form. Unfortunately, I did not get the metal. But thorium is everywhere, and it's easy to extract, and it can be used for electrical power generation. If you are concerned about climate change, thorium should be the top priority. If you're concerned about reliable energy for the future, thorium should be the top priority. If you're concerned about nuclear terrorism, thorium should be a top priority. Don't believe me? You don't have to. The data speak for itself, and whoever can read and understand them. If you want to do something for the planet, this is the solution that makes sense. Constructive criticism is always welcome. So, this is probably not your first YouTube video, and you know what to do. Thumbs up if you like it, subscribe if you want, Patreon, bell, share. I hope to see you again on the next one, and thank you for watching.
Damn it!